Welcome back, dear students. So we discuss the probability theory, that is model 3 probability theory. In the last video we discussed the discrete probability distribution. Okay, so in discrete probability distributions, if the outcomes are finite in number, then we can say that discrete probability distribution. In discrete probability distributions, two concepts we can apply, that is a binomial distribution and Poisson distribution. So the binomial distribution is if P is the probability of success and Q is the probability of failure. P is probability of success, Q is probability of failure. Then the probability of X success out of n trials is P of X is equal to NCX P raised to X Q raised to n minus X, where X is equal to starts from 0, 1, 2, 3 and so on to n, comma. P and Q, these are always greater than 0. Success and failure are always greater than 0, such that P plus Q is equal to 1. That is, success plus failure is equal to 1. Always this condition should be satisfied, and P and Q are always positive numbers. Then the probability distribution is called as binomial distribution. Then after the binomial mean, can define this binomial mean by deriving using this equation. We can get the binomial mean, it is NP, and variance it is NPQ. So to apply the binomial distributions, two things we have to concentrate here. One, it is probability of success rate is very high, that is 0.1 to 0.9, and number of trials, n value, number of trials, it is small in number. Okay, say 5, 10, 12, 15, below 20. If are there, then we can apply the binomial distribution. You can easily get the solutions. Okay, success rate is very high and number of trials are very small in number. So let us discuss one example. Okay. So the probability of a pen manufactured by a factory to be defective is 1 divided by 10. If 12 such pens are selected randomly, then what is the probability of exactly 2 defective, at least 2 defective, none of them defective, at most 1 defective. So in this problem they are not mentioned the any distributions, either Poisson, binomial, normal, exponential. Okay, depends upon the n value, p value we can identify. Just identify the given data. So pen manufactured by a factory, that its defective given it is 1 by 10. It is the probability of the defective pen. We can denote it is p. Okay, it is 1 by 10. 1 by 10 means it is 0.1. Probability of success rate it is 0.1, and 12 such pens are selecting. So it means that total number of trials, that is n is equal to 12. Now just see here, P it is 0.1 and 12, n is equal to 12. So both are, n is very small number and probability of success rate it is very high. Then we can apply the binomial distribution, depends upon these two. Now the probability of non-defective pen is, that one we have denoted is Q. Q is equal to 1 minus P, because we know that success plus failure is equal to 1. So Q is equal to 1 minus P. So 1 minus 0.1 it is 0.9. Okay. So in problem always we should consider the success rate and number of trials only. Okay. Then we can define the binomial distribution. P of X is equal to NCX, P raised to X, Q raised to n minus X. Just substitute here n value, we know that 12, P value 0.1 and Q value 0.9. So P of X is equal to 12CX, 0.1 raised to X, 0.9 raised to 12 minus X. Now we can find out the, so we can put the X value. So X value we get here from these conditions. Okay, in that X condition, if X denotes the number of defective pens. Okay, so first condition is exactly 2 defective out of 12 pens. In that one 2 defective. So exactly 2 defective means put X is equal to 2, because X denotes the defective pens. Put X is equal to 2. So 12C2, 0.1 raised to 2, 0.9 raised to 12 minus 2, and on simplifying we get it is 0.2301. So out of 12 pens, in that one if you consider 2 exactly defective, then its possibility becomes 0.2301. Second condition, at least 2 out of 12 pens, minimum 2 are defective. Okay, maximum it will take the out of 5, 10, 12 anything. But at least 2 means it is P of X is greater than or equal to 2. That is, probability of X is greater than or equal to 2 means we can convert it. Here 12 pens are there. So P of 2, 3, 4, 5 up to 12. So it is a calculation, it is very lengthy. So we can convert that into the maximum. So 1 minus P of X is less than 2. 1 minus, here greater than or equal to 2 there. So X is 50 less than 2. So X values are starts from 0, 1, 2, 3. We have defined. Okay, 1 minus P of X is equal to 0 plus P of X is equal to 1. In this equation, put X equal to 0, put X equal to 1, and simplify. 1 minus 12C0, 0.1 raised to 0, 0.9 raised to 12 plus 12C 0.1 into 0.9 raised to 11, and on simplifying we get it is 0.341. So out of 12 pens, if you consider at least 2 are defective given, then its probability of possibilities it is 0.341. The next it is none of defective, means out of 12 such pens are selecting, in that one there is no defective pens, means put x is equal to 0. So 12 is 0, 0.9 raised to 12, and on simplifying we get it is 0.2824. If you consider 12 pens such are good conditions, then its possibilities become 0.2824. Next, fourth condition, at most one defective. So out of 12 such pens, in that one defective pen is there. So it means that one defective means p of x is less than or equal to 1. P of x is less than or equal to 1 means p of x equal to 0 plus p of x equal to 1. Put x equal to 0 and 1 in this equation. Simplify. 12c0 0.9 raised to 12 plus 12c1 0.1 into 0.9 raised to 11, which is equal to 0.659. So if you consider out of 12 such pens, in that one defective, at most one defective means its possibility to become 0.659. So these are the problems on. So here you have to remember to apply the binomial distributions, these two conditions are very important. Probability of success rate is very high and number of trials are very small in number. If this condition satisfies, so we can easily apply the binomial distributions. So in the next video, we discuss the Poisson distributions. Thank you.